we're going to use some sum and difference identities to verify the following. So the first one here, we have a sine of 3 pi minus x. We want to show that that's equal to sine of x. So let's take a look at the sine of 3 pi minus x. So we want to find something in our list of identities that kind of looks like it. Now we have a sine and we have a subtraction here. So you can look at your identities and you can see this one kind of looks like it. This would be like the x in our table and this would be like the y. So we're just going to work the left side until it looks the same as the right side. So I look at my identities, what it is equal to, and it's sine of x, cosine of y, minus cosine of x, sine of y. So let's substitute that in. So we have sine of x, or the first one, so which is 3 pi in our case, cosine of y, which in our case is the x, and then minus cosine of the x, or the first, which again is 3 pi, and then sine of y, which in our case is actually the x. Okay, so we want to simplify this now. So this is using the unit circle now. So the sine of 3 pi. Okay, so if you think about a unit circle, I'm going to draw the coordinate plane up here. Pi is over here. So if we go around to here, that's pi. This would be 2 pi. And then if we go another half around, that gives us to 3 pi. So we look up on our unit circle, what is 3 pi, sine of 3 pi? And if you look at it, you will discover that the sine of 3 pi is equal to 0. Okay, so this is 0 times cosine of x. Okay, minus, now we look up what cosine of 3 pi is. So we're in the same place, but now we're looking at the terminal points. We're looking at the x-coordinate, and the x-coordinate is actually -1. Okay, and then we have sine of x. We just write that down because we can't simplify that. So the first term actually crosses out because anything times 0 is 0, and the second term is minus -1 times sine. So this is equal to just sine of x. Okay, so then the next one is cosine of pi plus x. So again, look at your table. What does it look like? So we can see it looks like this guy right there. So we're just going to substitute in what that is equal to. So this is equal to cosine of x, or the first thing, which is the pi in our case, cosine of x. And then our formula says that even though it's cosine of pi plus x, in our formula, the other side, there's a negative, so make sure that you subtract sine of the first, which is pi, times sine of the second, which is x. Okay, so again, just like in the previous problem, now we go ahead and simplify what that's equal to. So cosine of pi. So again, we're at 180 degrees. We know that's the x-coordinate of our terminal point, and it's -1 times, we have cosine of x minus sine. So when we look at that, that's equal to 0 times sine of x. So this cancels for this problem. And we still have -1 times cosine, so that's negative cosine of x. Okay, so then the next one, it has cosine and sine in it. So it's kind of we have to plug in two formulas. So let's take a look at the first one. So the first one is similar to what we did in the previous problem, but now we have a subtraction. So it's actually the second formula for cosine. So let's plug that in. So we have cosine of pi cosine times cosine of theta, and then we have plus sine of pi, sine of theta. So that's the first part of our equation, but then we're going to add to it. Now look at this. This is, if we look at the table, it's the first one, because we have sine of x plus y. Now in our particular case is sine of pi over 2 plus theta. So let's substitute that in. So we have sine of pi over 2 cosine of theta plus cosine of pi over 2 sine of theta. Okay, so now that we have it all written out, we're going to simplify each one of the expressions that has an angle plugged in. So as we go through, we have cosine of pi, which we know is -1, times cosine of theta, plus we have sine of pi, we know that's 0, times sine of theta, plus sine of pi over 2. Okay, so we know sine of pi over 2 is equal to 1 times cosine theta, and then plus cosine of pi over 2, we know that's 0 times sine of theta. Okay, so let's cancel some things here. So this term goes away, and this term goes away. Okay, so what's left over is negative cosine of theta, and then plus cosine of theta. And that equals 0. Okay, so we have one more. We have the tangent of pi plus theta. So as we look at our formulas, we see that this corresponds to the first one of the tangent formula, since it's an addition. So let's replace that with our formula. So tangent of pi plus tangent of theta over 1 minus tangent of pi tangent of theta. Okay, so now I just go through and simplify. Now tangent of pi, that's equal to 0. And right here we have another tangent of pi that also becomes 0. Which means that on top, what I have left is just a tangent of theta. But on the bottom, because this whole thing, it's 0 times tan of theta, that just becomes 0. So all I have left on the bottom is 1. So that's tangent of theta.